Bismillah ar-Rahman ar-Rahim. Hi dear third year medical students. We will talk today about statistics, introduction and definition. This is a very important subject. Why it is important? Because we need it in our studies and in our research. First of all, the branches of statistics. There are two branches. Descriptive statistics, which refers to the method of data collection and organization, classification, summarization and presentation. So it is just descriptive. While inferential statistics, or we call it the analytic, it refers to a process of arriving at conclusion about a population, but this based on information obtained from a sample. So we have descriptive statistics and inferential or analytic statistics. The biostatistics is when the data are derived from biological and medical science. We call it the biostatistics. This is very important. Why it is important? What's the advantages? First of all, carrying out a research. Statistical analysis should be considered in the planning phase of the study. And number two, evaluating published articles. Statistical errors are common in clinical research that may invalidate the conclusion. And third, ethical consideration. It is unethical to use erroneous statistics, especially in scientific publication. Using harmful or ineffective treatment or avoidance of useful treatment can occur if statistics is wrong. And fourth, it is a professional and personal satisfaction if applied by statistics in a proper way. So what are the purposes? The data reduction. As you know, the data is maybe so big information, we have to condense this data to a manageable proportion and thus facilitate interpretation, and this is one of the purposes of statistics. And number two is dealing with variable subject matter to see the effect of a certain event is a real one or maybe arise from chance fluctuation because of a sample of object. So we have to choose a correct sample and to find a certain way by statistics to know whether this event is a real one or maybe it is by chance. Sampling and generalization is the third purpose. Here, what a proportion of discharged patients required readmission, what are their characteristics, and the answer required generalization of the sample result. So we have to answer questions and we have to apply this answering from the sample to a general population. What's the application? Application here, first of all, are the difference between the groups significant? Yes, of course, it depends on the biostatistics, on different statistical way to find whether this is significant difference or not. And are these two measures related or associated or not? Also depends on statistics. And can one predict the value of one variable from knowledge of the variable or values of other variables? And this is also can be done by the statistics, different method in statistics. And now we will talk about the variable. What do you mean by variable? Variable is characteristic that takes different value in different person, places and things. Maybe the age or gender or weight and so on. So these are different variables. Whether they are qualitative or quantitative, we have to know. Quantitative variable that can be measured in the usual sense of measurement, like the age, weight, height, these are quantitative, while qualitative they cannot be measured and maybe fall into category as in socio-economic status and diagnostic categories, mild, moderate, severe and so on. So there is no clear cut line measured. Like, for example, socioeconomic state. And there are different types of variables. We have discrete variable. It is characterized by gaps or interruption in the value that can assume as number of admission or decades. And we have continuous variables. We mean here it doesn't possess the gap of interruption, like age, like height, and the mid-arm circumferences. These are continuous variables. We have the variable scale. How many variable scales we have? We have a nominal scale. It uses names, numbers, or other symbols. Each measurement assigned to a limited number of ordered categories and fall in only one category, like male or female. Either he is male or she is a female. And for example, another example, what is your hair color? Also, there are a limited number of categories, and the answer should fall in one of these categories, either brown, black, blonde hair, gray hair, or others. And now we have the variable scales. Variable is one of them is the, as we said, the second one is the ordinal scale. Each measurement is assigned to one of the limited number. We have also limited number of categories. They are ranked in a graded order, and differences among the categories are not necessarily equal and often not measurable. For example, how do you feel today? Very unhappy or unhappy, okay, happy or very happy. So these are limited numbers and different categories. They are not measurable. And how satisfied are you with our service? Very unsatisfied, somewhat unsatisfied, neutral, somewhat satisfied, and very satisfied. So these are the categories. They are also limited and it is not measurable. We have an interval scale. Each measurement is assigned to one of unlimited, here it is unlimited categories, and that they are equally spaced with no true 0 point. So we have unlimited category to the left and to the right, and we have minuses categories, but there is no true 0 point. And we have the ratio scale. Measurement begins at 0, true 0 point, and the scale has an equal intervals. So there is intervals and there is 0 point, and also it is arranged. So scale of measurement, what is a nominal scale? A scale that categorized items. And what is the ordinal scale? It is not nominal, it is ordinal. The scale is that categorized and rank orders items. What is interval? A scale categorized and rank order item and has equal intervals. What is ratio scale? A scale categorized, rank order items, equal intervals, and 0. That means absence or none of the things being measured. So these are the difference between different types of scales. Now what about population? How we define the population? Either according to population of entities, so it is a large collection of entities that had a common characteristic for which we have an interest at particular time. So they have a common characteristic and we want to study these characteristics. So we choose the population who carries these certain characteristics that we want to study. Or population of variables, which is the largest collection of value of a random variable for which we have interest at particular time. And the sample, it is part or subset of population. Either it is sample of entities, as we said, they have certain characteristics we want to study, or variables, they have a largest amount of variables and also we want to study. Presentation of data, other is it is mathematical, tabular, graphical, and pictorial. So we have a group data. To group a set of observation, we select a set of contiguous, non-overlapping interval, such that each value in the set of observation can be placed in one interval only and no single observation should be missed. The interval is called the class interval. So as here in this example, we have the height, we have different intervals, and the number of students for each height of student. So the interval here is from 146 to 150, and the second interval from 151 to 155. So here we have only number 1 student, here we have 0 student, and so on. So these are the number of students, and here we have the interval types. So the number of a class interval should not be too few because of loss of important information, and not too many because of loss of needed summarization. We have the number of a class interval when there is a priori classification of that particular observation we can follow that classification. But when there is no such classification, we have to follow Sturge's rule. Sturge's rule here, it is equals to K equals to 1 plus 3.322 log n. K is the number of class interval and the n is number of observation in the set. The result should not be regarded as final because modification is possible. So we have an example here, and the width of the class interval should be, the width is equal to the R over K. R is a range from the largest value minus the smallest value, and the n is a number of a class interval, and the W is the width of that class interval. We have to know the frequency distribution determines the number of observation falling in each class interval. What about the relative frequency distribution? It determines the proportion of observation, in particular class interval, relative to the total observation in the set. So we have here the weight in kilogram, for example, 50, 60, 70, and so on. The frequency here, how often we have weight of 50? 10. This is the frequency, 10 times. We have students and the weight about 50. And from about 60, it is 12 students. And the weight about 75 students, and those who are weight 55 are 13 students, and 40 is 10 students. So the relative frequency is the division of the frequency over the total. We have to collect or to sum these frequencies together, and their summation is equal to 50. So 10 over 50 is 0.2. So this is the relative frequency of the weight 50, and 12 over 50 is equals to 0.24. This is the relative frequency of 60 kilograms weight, and so on. Cumulative frequency, this is calculated by adding the number of observation in each class interval to the number of observation in the class interval above, starting from the second class interval and onward. So this is the cumulative frequency here, and we have, for example, the class interval, and this between 60 to 75, and we have two members having the same mark, and the frequency is only 2, and here the frequency 4, 6, 2, and 6, 4 according to the class interval. So cumulative frequency, we have two. First one is the same because there is no other added number in front of it, while here the number two, this one is the collection of number 2 here and the one above in the cumulative frequency column. So the summation of 4 and 2 is 6, and number 3 here, the number is taken from where? From the summation of 6 and 6, it is 12. Number 14 is the summation of 2 and 12. Number 20, summation of 6 and 14, and this one from the 4 and 20. So this is the cumulative frequency distribution. Cumulative relative frequency distribution is calculated by adding the relative frequency in each class interval to the relative frequency in the class interval above, starting also from the second interval. So this is the cumulative relative frequency. And how we calculate this, as we said here, we have to take the figure from there. So it is 0.2 here, and it's the same 0.2. And the second number is summation of this one and that one. The second, the first one, equals to 0.4. And the third and the second here is equal to the below figure, and so on. Cumulative distribution is the cumulative frequency and cumulative relative frequency distribution are used to facilitate obtaining information regarding the frequency or relative frequency within 2 or more contiguous class interval, and we will discuss later on. So what about the exercise here? The following are the number of hours of 45 patients slept following the administration of a certain anesthetic. So we have different numbers of hours of patients slept after anesthesia. We have to arrange these figures in a proper way. So we have here how many patient, we have 45 patients. And the yellow is regarding the hours, the number of hours. So first patient, he slept 7 hours, the second 12 hours, and the third patient 4 hours, and so on. So we have to make a table, and we have to know from the table, we have to find the frequency, relative frequency, cumulative frequency, and the cumulative relative frequency. So the number of a class interval is equals to 1 plus 3.322 log n. And here log n is log 45 because the patient is 45, and the result here is 6. So the number of a class interval is 6. What about the width of a class interval? It is the difference between the largest point, the largest number or figure in the table, minus the smallest figure in the table. So it is 16 over the k, which is a class interval count. Here it was 6. So the difference between the largest and the smallest figure in the table divided by the number of class interval, it will be 2.7. It is, as we said, it is not final because we have to modify it, and the figure here is 3. So how we know we have to divide them to different intervals. It is 6 intervals, 1, 2, 3, 4, 5, 6. There are 6 intervals, and the width is 3. So it is start from number 1, 2, 3, and number 4, 5, 6. This is the width of the interval. So each class interval of the 6 interval, the width is 3 only, and the frequency of these numbers in the table 1, 2, 3 is equal to 11, and the frequency of these 3 numbers 4, 5, 6 in the table is 10 times, and the frequency of 7, 8, 9 is 13 times from the table, and the frequency of 10, 11, 12 is only 7, and the frequency of 13, 14, 15 in the table is 2, and the frequency of 16, 17, 18 is 2, and the total, as we said, it is 45. So this is the frequency. Cumulative relative frequency is the percentage of the number of frequency over the overall or total number of frequencies, and then we have to multiply by 100. So this is the relative frequency. It is the percentage of the partial on the total, partial on the total. So it is 24.4, and for the second one here it is 22.2, the third is 28.3, the seventh is 15.6, and the second one is 4.4, and the second is also 4.4, and the total number is equals to approximately 100. Cumulative frequency here, how we take this cumulative frequency? By checking. We have number 1 is the same frequency added because there is no previous number to add, and the second one here, it is from addition of 11 and add the second number in the frequency column. It will be 11 plus 10, it will be 21. 21 plus 13, it will be 34. 34 plus 7, it will be 41. 41 plus 2, it will be 43. 43 plus 2, it will be 45, and so on. So these are the cumulative frequency. How we calculate for the cumulative frequency, relative frequency, cumulative relative frequency? Here this one is the same, and the second one is the collection of 24.4, and the second one here, and this one, and this one, this one, and this one equals to that figure. This one and this one equals to this figure, and this one and this one equal to this figure. This one and this one equals to this figure. And this is the way how we collect the cumulative relative frequency. So we have an exercise. The following are the weight in ounces of malignant tumor removed from abdomen of 57 subjects. So these are the 57 subjects, and these are the weight in ounces of this tumor. So first of all, how to construct the table? You have to put in random way. And then we have to know the frequency, relative frequency, cumulative frequency, and cumulative relative frequency. First of all, we have to know the class interval. How we know the class interval? By Stir's rule. K is equals to 1 plus 3.322 log n. N is 75, and the result was 7. And the width also we have to know it. It is R over K. R is interval between the highest figure and the lowest figure in the table, and we will divide it over 7, which is the K. The K is the class interval, and it equals to 10. So the width is 10, and the number of the class interval is 7. So we have to put a table of 7 class interval. This is number 1, number 2, 3, 4, 5, 6, 7, and the width is 10. So from 10 to 19, from 20 to 90 to 29, and so on. The frequency here from class interval 10 to 19 is 5 patients of this weight in pounds, and 19 patients they have tumor of this weight in pound. 8 patients they have this weight in pound of the tumor removed from their bodies, and so on. So these are the numbers of patients with the approximate weight tumor removed from their bodies. So the cumulative frequency is how we check the cumulative frequency. We know this is the frequency, and relative frequency is number 1 is remain the same, but the number 2 is the estimation or the collection summation of this one and that one, the second and the one previous, the second, the third, and the one previous, the fourth and the one previous, the eighth and the one previous, and so on. So 24 is the summation of 5 and 19, 34 is summation of 24 and 10, 47 is the summation of 34 and 13, 51 is the summation of 47 and 4, 55 is summation of 51 and 4, 57 is summation of 55 and 2. So this is the cumulative frequency. What about the relative frequency? Relative frequency is the partial or part over all, and we have to multiply by 100. So 5 over or divided by 57 multiplied by 100 is equals to this figure, and 19 divided by 75 multiplied by 100 is equal to this figure, 33.33, and 10 divided by 57 multiplied by 100 equals to this one, and so on. And we have, when to calculate these together to be sure that we are right, it will be 100. Cumulative relative frequency, and this is here, the first one is remain the same. We have to put it in the first place. The second place here, it is a summation of this one and that one, and the third place is summation of the third and the one before. The fourth space here or place here, it equals to the summation of the fourth plus the one before. The fifth is from the summation of the fifth and the one before, and the sixth is the summation of the sixth here and the one before. And lastly here, the seventh is equal to this one plus the one before. So this is the cumulative relative frequency. Thank you.